Okay, welcome to molecular spray. What we have here is the UHV4i electrospray deposition source, and attached to that we have the UHVX additional differentially pumped aperture assembly. And if I just turn the laser on, then you should be able to see that we have a very nicely aligned system with a laser spot shining on the card there. So how do we do that? This is broken down into a couple of sections. The first section is making sure that the exit aperture of the UHV4i is actually aligned. Chances are that if you're attaching this section here, then you might have made some alterations to the orientation of this rotatable flange here. After all, these two ports have to be attached somehow to turbomolecular pumps, and depending on the size of those pumps and the orientations, you might want to change the orientation of this exit flange here. So I'm going to start on the assumption that nothing down here has been modified, and that I'm going to remove the exit aperture and then make sure that that's aligned with the laser, and then from there we could go to the lab. We could attach the source to the preparation chamber of our UHV system, for example, X-ray photoelectron spectrometer or scanning tunneling microscope, or we could, as we've done here, attach the additional differential pump aperture, and then of course we could then go and mount it on the chamber. We should, under normal circumstances, not disturb the three socket cap screws which hold the exit aperture in place on this T. So usually we'd be really careful not to disturb those, but in this case it doesn't matter because we're going to remove it anyway. Okay, so we've removed the additional stage. You can see the laser light shining just through the UHV4 system. And now ordinarily you wouldn't do this, but for completeness I'm going to remove the exit aperture . So the basis of this procedure is that we have the laser shining in through the entrance capillary, and to make the laser spot easier to see, we've changed the entrance capillary from one that has an internal diameter of 0.25 millimeters, which is what we use when it's pumping and when we're attached to the deposition chamber in order to do a deposition. We've changed it to one that has an internal diameter of 0.5 millimeters, which is a yellow banded capillary. And this just makes it easier to see the laser spot. When we do the alignment with the preparation chamber in a different video, that will be using the normal blue banded 1/4 millimeter one. But by then we know that everything is all nicely aligned. The other thing that we need to do is we need to mount the system vertically like this, so that when we attach additional elements on top, we can do so without worrying about the lateral forces. And so we've mounted it in this case on a special adapter, which is designed for holding 2 3/4 inch or 70 millimeter outer diameter UHV flanges. And The laser is mounted in the same type of manipulator that is standard on the molecular spray sources. If you have the older style manipulator with the V mount, then you can mount a round laser directly into that. Here is the more modern version, which relies on machined blocks for the to hold the head, the electrospray head, and in this case we've made an additional mount for the laser. But the important thing is that we have the 5 axes of movement. We can move in X, Y and Z. Actually Z is irrelevant, just X and Y, and also the pitch and yaw, because obviously the laser is incredibly collimated and we want it to go through the entire stack, so we have to be able to move the laser in those axes. Just some thoughts in terms of the laser here. If you are making a bracket that you can mount using M4 bolts to the platform of the manipulator, then it doesn't really matter what size laser you use. If you have one of the old V-type blocks, then you'll need the diameter of the laser diode to be quite small. You can also use a laser pointer, but you will have noticed that this laser's been on now for quite some time, and it doesn't matter because it's just powered. This one is just powered with the USB plug top adapter, whereas a laser pointer would be using batteries, and the batteries in a laser pointer run out very quickly. They're not designed to be continuously on in this way. And then the problem that you have is that if you mid-alignment want to change the batteries in the laser pointer, you'd have to take the laser pointer out, and then when you put it back in, you then are not in exactly the same position, and so you'll have to re-optimize the position of the laser, which again is going to take some time. And so I would recommend getting a laser that you can make an adapter for and power it with a DC power supply. So I've deliberately messed up the position of the laser, so it's no longer aligned with the capillary. So how do we find that? Well, it's easy in this situation because we don't have an exit aperture. Now we know that these elements are aligned, so we know that as soon as we have the laser aligned with the entrance capillary, it's going to go through the other elements, and we're going to be able to see a spot up here. So if we just put a clean cap on the top there, then what we can do is move the laser around a bit, and the easiest thing is to make sure first of all that X and Y mean that it is actually shot. It's actually shining on the end of the capillary, and that will give us a fighting chance. And then we can, you probably can't see, but I can see that there's a spot emerging and it's getting brighter. There you go, now you can see that as well. And then we can just adjust the pitch and yaw to maximize the intensity of that spot, and then also maybe moving in X and Y, make sure we've got the brightest part of the beam. Okay, so now we've got our laser spot. I guess we can see it as well on the screen. You can't see, but I can see it on the ceiling as well. And once you see it on the ceiling, I can't adjust the camera to see that, but once you have it projected onto the ceiling, you can fine adjust a little bit more so that you can even see in some cases some diffraction rings around the central spot, and if you centralize that, then you know that everything is nicely aligned. You can't see those diffraction rings here because the spot is too small. So now it's a case of reattaching the exit aperture. You'll see, as with everything, the whole system is held together with Viton gaskets. This allows the faces of these flanges to sit flush with one another, which you don't get with a copper gasket. And we put in, first of all, quite loosely, the three bolts into the threaded holes on this exit flange. Just loosely, and then again with our clean cap we can see the laser spot, and we can just move the flange around to just check where we get the brightest spot. And if you can project onto the ceiling, then you get an even better picture of what's going on. And I can see that it doesn't matter what orientation I pick, as long as the exit aperture is central, then I can see a nice spot. Now this is your opportunity to change the orientation of this rotatable flange. So if you need a through hole in the up position, or if you need it at a 30-degree position, depending on how your valve is mounted and how you want all the other elements to sit in relation to the prep chamber, then now's your opportunity to pick an alignment. Now I usually pick this orientation so that I have easy access to all three of these bolts. Now, the other advantage of this orientation, if we are then going to attach, as we are, a UHVX stage, is that the mounting flange of the UHVX is not rotatable. So ideally we want the exit to be in alignment with the entrance holes of the mounting flange of the UHVX, so that we're happy with the orientation of that stage, like this. Oh, I can see that that's pretty much spot on. The pumping port of the UHVX is in line with the pumping port of the UHV4. Okay, so now I have my perfectly aligned UHV4i source. One question would be, well, how would you go about doing this if you didn't have access to this end, you know, if it was already mounted to a chamber? And the answer would be to look through one of the stage 1 or 2 pumping ports. This is a view through the stage 1 pumping port, and so you could maximize the laser in there, and then you know that the laser is going through the capillary. So now we're at the stage where we want to mount the UHV-X. And having confirmed that the laser spot is going into this chamber, we want to show that it is coming out as well. And so we can just move it around a little bit. You notice I haven't put a gasket in or anything now. I'm just checking that there is a position where I get a nice intense spot. And ideally that position would be where these flanges are exactly aligned. But of course these T-pieces have a little bit of a tolerance in them, and so that's not always the case. But it should be, of course, within the tolerances of the Viton gasket and the bolt holes, otherwise it's never going to work. So now, having confirmed that, I can then go ahead and mount this. Now, because I'm going to mount it in an orientation where the two pumping ports are aligned, it will mean that I can't get the studs in through the other side because the T-piece is in the way. So I need to put two of them in beforehand. And I can mount this, and then drop the others in. Before I tighten these in any way, I'm just going to make sure that I can put the nuts and washers on this end. And then I can go ahead and put the nuts and washers loosely on the other end. And now I can use my laser, make sure that I move this into position to maximize the intensity of the beam. And then I'm having to put a tiny little bit of lateral force on here . And then I'll tighten one of these screws and this one. Okay, now maybe this exit aperture is not perfectly aligned either. We just took the UHV-X stage and we just put it on, and the exit aperture was already mounted. And so to double check that, we can then loosen these bolts. And of course, the beauty of the Viton gaskets is that we don't have to then go in and replace them as we would if they were copper. So we can do this as many times as we want to make sure that we've maximized it. So I'll loosen it a little bit more. And again, this is an opportunity to change the overall orientation of the system with respect to the chamber that we're mounting it to, as we can change the orientation of this exit aperture. Okay, so I found the optimum position. Just put the laser there, you can see, so that's the brightest laser spot, and I can feel that I need to put just a little bit of lateral force on the one side as I'm tightening these, and then that will keep it all in place. There we go, and that's all ready now to be mounted. But in preparation for the next video, what I'm going to do now is remove the UHVX stage. I'm going to take this over to the lab, and then in the next video we can do the alignment on the system and find the position on the sample.